Alright, hi guys, it's Mr. Ivan here. Today we're going to be going over the volume challenge question, which can be found on the 8th grade second semester review, and it is question number 10. This is my first time recording this, so please forgive me for any troubleshooting, any audio issues, and if something's wrong, just please let me know. We're going to be doing this one because Kaylin's already asking for challenge problems, and might as well test this out to see if you guys, will even use it. So just a general tip that I've always done is always just go through the problem, right? So let's read it. The innovator rides in 8th grade class is going on a field trip to Egypt. On the trip, they visit the Great Pyramid of Giza. That doesn't really have any information that we really need. Next, Mr. Ivan tells the class that the Great Pyramid has a square base. This is pretty important when it comes to volume. While standing at a height of 140 meters tall. Okay, that's great to know. Before coming here, they saw two other pyramids. Mr. Ivan tells the class that the Great Pyramid has a base that is 2 times the base in area of the first pyramid they saw. That is pretty important. And then it lets us know that the first pyramid they saw had a rectangular base with a width of 5 meters and a length of 23 meters. So actually, here I'm going to change these colors. The green information is pertaining to the Great Pyramid. Let's go red for this next one. Right, the first pyramid we saw had these dimensions. And then it tells us the last pyramid had these dimensions. It had a width of 7 meters and a length of 16 meters. It also tells us that the height of both of the small pyramids is 1/4 the height of the Great Pyramid. That is essential because it never specified specific value for height. Now, it's asking us what is the volume of all the pyramids combined and what is the volume of each individual pyramid. Obviously, if we find B, we'll know A, so we might as well do B first and then just add them up for A. I have here a little sticky note. These are some formulas that are pretty important to know. If you don't know these things up to the top of your head, there's the review guide right here. You'll always be given formulas, but these are just great to know. Volume's pretty important. So the formula we're using is the one listed here for a pyramid. And these are the formulas for volume. This first formula is just for area, okay? So I already drew these to save us some time, but there's only a few things I want to highlight. You guys notice I specifically made a square base on this one. That's what it told us, okay? I also made a rectangular base for both of these because that's what it told us. Now, you don't have to do as I do here. You don't really have to be this in depth. This is just because it's a video for you guys. You could have simply just put pyramid 1, the width is equal to this, the length is equal to this, and the height is equal to this, right? This applies to every single one of these. Now, let's go over what we know. So we know that this height is equal to 140 meters. You can't forget the units. We don't know what these are. We have no idea, right? All we know is that the total area of this little base is going to be 2 times the area of pyramid 2. Okay? So we just know that this is going to be 2 times the area of pyramid 2. That's just a little note I'm writing to remember that. Now, we're told that the height of these two pyramids is 1/4 the height of the great one. So, if you have a calculator, you can just go ahead and, figure that out by doing 1/4 times 0.25. It's 0.25 because 1 divided by 4 is equal to 0.25, okay? So, if you have a calculator, go ahead and do that. If you don't, the way I approach these problems is this is the whole pizza. This is the amount of slices. We're trying to find out how much one slice is worth. And to do that, it's as easy as drawing a division, a little box, right? The whole pizza goes inside. The amount of slices is outside. And you just approach the problem. 4 does not go into 1, so there's a 0 up there. 4 goes into 14 about 3 times because 4, 8, 12, 16 is greater. We're not doing that. That gives us 12. 3 times 4 is 12. A 2 is left over, and the 0 is dropped down. Now, does 4 go into 20? Yes, it does. And it goes into it an even 5 times. 4 times 5 is 20. 0, we're left with no remainder, so we can end there. So this is equal to 35 meters. Let me just check that on my calculator, otherwise it's going to be really awkward. And yep, that seems right. So I now know that both of these are 35 meters. Right? This little thing is just representing the height. We know that because it told us over here that the height of both the small pyramids is 1/4 the height of the great one. That's exactly what we just found. So that's why reading the problems is pretty essential. Now, we were told that the width of this rectangular pyramid was 5 meters and the length was 23. So I know my width here is 5 meters and I know my length is 23 meters. Like I said, if you're just going along this, you just fill in these as you do it. 5 meters, 23 meters, it is 35 meters. Now, left is pyramid 3 with length, height. We were told that the last pyramid, right, we're looking here, also has a rectangular base with the width of 7 meters and a length of 16 meters. Okay, so that's 7 meters and 16 meters in this case. And we know the height is 35. So let's just fill that out. We know this is 7 meters. We know this is 16 meters. And we know our height is 35 meters. Okay. I'm going to erase this here. Hopefully you guys, have this all written out. Excuse me. Okay. Now, let's explain something that might be a little confusing. This formula for a pyramid says the area of the base times the height divided by 3. That's what this sign means. It's the same exact thing as this division symbol, just nicer and easier to read. So, what that means is you need to find the area of the base. In this case, our base is a rectangle. It even mentioned it specifically in the problem. And, take a guess at what this base is. And hopefully you said a rectangle because that's correct. So basically, we need to find that area and then just multiply it by the height here, right? We need to take this area, multiply by the height. Same thing on this yellow one. We need to take that little area and multiply it by the height. Now, that should put everything together, right? That's why we only need to know the area of pyramid 2 because we were told that this one is 2 times that. And that'll give us everything we need. So now let's just start approaching these problems. Now, this is where all the math comes. And, we don't know these. So on this first one, we don't know enough to approach it, but we know everything on these next two. So let's start here. So I know that's a rectangle. I know for an area of a rectangle, it's width times length or width times, And I know that up here, right? This is from 7th grade. You should just know your areas. Okay, I know in this case, width is 5 meters, length is 23. If you have a calculator, go ahead and do that. Just gonna do it here, 15, 10, 115. And don't forget that there was a meter here and a meter here. 2 meters multiplied is meters squared. That's how all your units work. Area is always in meters, not meters. Area is always squared. So we know that area. We might as well just find the volume, right? If you look at this formula, the volume, oh, I guess I made a typo here. The volume of a pyramid. It's a little illegible, but okay. So the volume of this pyramid here is equal to the area of the base, which we know is 115 meters squared, times the height. We were told that the height is 35 meters, and that's what we're going to use. Okay? We're not done there yet. All of this is over 3. You can't forget that. I actually attempted this problem myself. I didn't do that, and I got the wrong answers, despite the fact that I made up the problem. Okay? I'm just going to use a calculator here. Obviously, you guys know how to line them up. and do all that, or at least I hope. So 115 times 35 is equal to 4,025. If you just leave this as your answer, you're incorrect in two ways. This is not divided by 3. There's no units. We times meters squared. With meters, there's an imaginary 1 here. 2 plus 1 is 3. And now we're going to divide this by 3. Just tell us that volume is equal to 1,341. This is the issue with making up problems, is sometimes we don't get nice numbers. We're just going to round to the nearest whole number, right? So this is actually 0.6. So we're going to round up and make this 1,342. So this is our volume. And if you notice, I don't have units, so this would get marked wrong. Meters cubed. Volume is always in cubes and area is always in squares. So now let's just do the same exact thing for pyramid 3. Right? If you want, pause the video and attempt it yourself. See if you worked it through. So I know area of a rectangle is equal to width times length. In this case, that's 7 meters times 16 meters. Imaginary ones here. It's kind of pointless to write them, but area is equal to, same thing, I'm just going to put it in a calculator just to save us some time. 112 meters squared. So that's the area of pyramid 3, but we want the volume. We know that the volume is the area of the base, which we just found here, right? Times the height. So that should be 112 meters squared. Height is 35 meters, right? We established that. Times 35 meters. Imaginary 1. And once again, we're working with volume, so this gives you 3,920 meters cubed. But if you notice, we're not done there. What do we need to do? Divide by 3. The volume is equal to 1,306.6. I said we're rounding to the nearest whole number, so that is, 6. But we had a 0.6, so we're rounding up. That gives us 1,307 meters cubed. Can't emphasize how important units are. All right, so that tells us the volume of these pyramids. This is technically part of the answer to B of each individual one, right? So I'm just gonna note that here. This is the individual volume of pyramid 3, and then the other one is obviously the individual volume of pyramid 2. Now let's go back to the Great Pyramid. So we were told on the Great Pyramid that the base is 2 times an area of this pyramid space, because this is technically the first pyramid we saw. The question specifically noted that. Now, if you can, pause the video and see if you could figure this out yourself. It's a bit of critical thinking required. So, if you have it, we found out that the area of that first pyramid base was 115 meters squared, right? Up here, if you remember, I wrote that this area was going to be 2 times that area. So I'm going to do 2 times 115 meters squared. That gives us 230 meters squared. Units stay the same because we're still, for one, speaking of area, and we didn't multiply by an m. So that's the area of this little yellow portion here. And if you notice, that gives us everything we need, because the volume formula is equal to the area of base, or I'm just abbreviating, times the height divided by 3. We have this, and this is always constant, so we can solve. So let's do just that. We're going to do 230 meters squared. We're going to do the height. The Great Pyramid, we were told specifically, is 140 meters. Now, if you notice, the new m came in. That's why we're going to have meters cubed. And once again, you can put this over 3. Now, if you plug this into a calculator, you got to have follow PEMDAS. Otherwise, calculator will always follow PEMDAS. But if you type it in wrong, not going to work. So what we're going to do first is multiply these two and then divide by 3 just to make sure we don't mess up. Right? So let me do that here. 230 times 140 is equal to 32,200. Obviously, we need to put that over 3. The units here are meters cubed already, right? Because we multiplied them. We're going to divide that by 3. Volume is equal to 10,733.3. We're rounding to the nearest whole number. 3 is not enough to round up, so it stays the same. We're going to box that. Once again, don't forget your units. Meters cubed. Now, this is also the last part of information we need to find B. Okay, so hopefully that all makes sense. There's not really any more clarification I could do. Now that we have all individual volume, I'm gonna erase this once again. Oh, that is not my eraser. Okay. Oh, I should not. Wait, no. Yeah, I could erase that. Okay. All right, cool. So let's just drag these out real quick. That's our volume there. This was our volume for this one. This was our volume for here. Okay. Just cleaning up my workspace. So those are the answers to part B. Part A just required us to the volumes of all the pyramids combined. So for part A, we're literally just adding the volume of pyramid 1 plus pyramid 2 plus pyramid 3. The area of that is equal to, sorry, the volume is to whatever the calculator gives me. So 10,733 plus 1,342 plus 1,307 equal to 13,382 meters cubed. We're still speaking in volume, so that's the unit that stays. And that's about it. Right, so there's our answer to part A. That's how we found the work to part B. I'll make sure my next problems are a lot nicer numbers and they're a lot more clear, but that's how we're going to work through this one. So if you're an avid and use this as a challenge problem, here's your solution. And please don't forget to do your names in pen when you do your binder check. Happens every week. So yeah, thank you guys for watching, and hopefully I helped you out just a little.